Okay, this is section 1.1 from MAT 1100, and in this section we are going to be looking at number one, rounding off to various places. We're also going to be looking at creating fractions, converting them to decimals, and then ultimately turning them into percentages. That will be the main theme throughout the chapter. We're also going to take our decimal version of the percentage and apply it to what's called a pie chart. So all of those things will be discussed in this video. Okay, let's start off with a little bit of a review of rounding to various places. So as you see right here, I have a little table for you or a little diagram for you, and it just reminds you of the names of the places. The places to the right of the decimal, those are called tenths, hundredths, thousandths, and 10,000ths, and so on. Everything ends in a THS when you're over on the right side of the decimal. Now you need to know the places by name, and if you don't think you're going to remember them, it is something that you should put on your index cards that you get to bring into the test, because the problem is going to start off by naming a particular place that you need to go to in the number, and they're going to name it, and if you can't locate that place, then you can't round it properly. So it's important that you know what place they're talking about when it's mentioned in a problem. The places to the left of the decimal, this number is in the ones place, this number is in the tens place, this number is in the hundreds place, this is the thousands place, 10,000s, the 100,000s, and the millions. None of these end in THS. So everything to the right of the decimal ends in THS, and then all of these do not. Okay, so let's go through some examples where we're going to apply what's on this table. Okay, we'll be looking at the table maybe as we do these first few. Okay, so now in this first particular problem, it says round to the nearest 1,000. Notice that this does not end in THS, so they're not talking about anything to the right of the decimal. Besides, you can see that this number doesn't even have a decimal. So the thousands place is, as you see right here, ones, tens, hundreds, thousands. It's a fourth number over. So it is this number that we are trying to make a decision about. That 4 that you see right there. We're trying to make a decision about either rounding it up or keeping it the same. And as this comment says right above the examples, it says, we look one place to the right of where we want to round to determine if we should round up. Okay, so you're always going to first pay attention to where they want you to round to. They want you to round the number in the thousand position. That would be this 4 right here. Look to the number that's to the right. Look at the number that's to the right of the place that you're trying to round off. And you know how it goes. If it's 5 or bigger, you round up. And if it's less than 5, you leave it alone. Okay, so I'll put that as my reasoning in case you look back at this. Since the number to the right is greater than 5, we round up. Okay, so this is going to be 1, 5, rounding it up. That 5 is in the thousand place, and then everything else to the right of the number that we just rounded up, everything else to the right of that number gets reported as a 0. Okay, in this next problem, we are rounding to the hundreds place. So the hundreds place, again, according to this table that I've given you up here, the hundreds place is in the third position over, ones, tens, hundreds. So ones, tens, hundreds, that's going to be that number right there. And we are just, again, making the decision about whether to round it up or whether to leave it alone. So we look to the right of the number that we're concerned with, and we see that it is 5 or bigger, and therefore this gets rounded up. So it's going to be 1, 4, 9. Rounding that 8 up to a 9, and everything to the right of the number that we are rounding off, everything to the right gets reported as a 0. And yes, you can put those commas in every 3 digits. Okay, so that is this. I mean, you're starting off with the same number in this problem and this problem, only this one they asked you to round to the thousand place, and here they asked you to round to the hundredth place. Okay, now we're going to move to the other side and look at the numbers that are on the right of the decimal. These didn't have a decimal portion, so we couldn't do that. But now you have 2 decimal type numbers. So now you might be asked to round something over here. You might be asked to round something over on the left. Okay, so now this is asking you to round to the 10th place. Okay, and then the 10th place, according to this table you have been given, is the first number to the right of the decimal. So you are being asked to round this number right here. Okay, so we're going to decide, should we leave it as a 1 or should we round it up? So we look at the number right next to it. That number is not strong enough to bump this number up, so we leave it as is. So it's 505.1. And everything that is to the right of the number that we're rounding off, we were rounding off this 1, and anything to the right of it gets reported as a 0. Now in this particular case, these zeros that are at the end, you don't have to report them when they're on the right side of a decimal. So it would be 505.1 is the same thing as this. Either one of those are considered the same answer. Whereas you must give the zeros for these type of numbers that are on the left side of a decimal. Okay, let's go ahead and do example 4. This time we are going to round the number in the hundredths place. So we're making a decision about the number that's in this position. Okay, according to this table I've given you, it goes tenths and then hundredths place. So the second number to the right of the decimal. So that would be this one right here. We always look at the number to the right of the number that we're concerned with and ask ourselves, is that number strong enough to bump it up? And it is. Anything 5 or greater, you are going to round up. So this is going to be 505.15. Anything to the right gets reported as 0. This answer that I've just given is the same thing as 505.15. Okay, now we're going to practice. And I do want to mention that in many of the problems, some of your points are going to come from rounding off. So don't assume that you can just leave the answer. You're going to see that many of the problems will say to round to a particular place, and that's exactly what I'm going to be giving you credit for. Part of the credit will come from there. So we need to, we needed to review a little bit so that you don't lose points on problems like that. Now we come to operations concerning fractions and decimals and percents. So let's first start by defining what percent means. Percent means, we're going to just fill this in, parts per 100. In mathematics, the word per is the same thing as divided by. So you're going to see that in a lot of these problems, you're either going to create your own percent, or they will give you a percent and ask you to write it in other ways, in alternative ways. And one of the ways that a percent can be written is as a fraction and also as a decimal. Let's look at the type of problems that they're giving us in examples 1 and 2. Okay, so this says that there are 400 police officers, and there are 280 of those 400 are males. So when it says what percent are males, then you have to think of doing a percent in this manner right here. It is the part compared to the whole. Like for instance, this is the entire, or you could call it the whole population. The entire population. And this is just part of the population, the males that belong to this group of 400. This is part of the population. So when you are setting this, when you're trying to turn it into a percent, you're always going to start off with this definition right here. You're going to be comparing the part of the population to the entire or the whole population. So this would be 280 divided by 400. And you can put males if you want to. You can put that this is males. You can put this as officers. But really you don't need the units because you are just trying to turn this number into a percent. Okay, so this is step 1 where you create the fraction. You set up the fraction. Always putting the smaller number on top, larger number on bottom. So that you're comparing the part of the population to the whole population. Step 2. Step 2 is where you are going to turn it in to a decimal. And that is done by your calculator. Okay, so simply put into your calculator 280 divided by 400. Whenever you are putting this in your calculator, you always have to enter the top number first. This means divided by, and then 400. Okay, so we're going to put that in there. 280 divided by 400. And you can see that turns out to be 0.7. Okay, so now we have a decimal. And the next step, the final step in going into a percent, it's just 3 steps, is that you are going to multiply this decimal that you now have by 100 in order to turn it into a percent. When you multiply by 100, which is what I'm about to do, that's the same thing as sliding the decimal 2 places over. And that's because multiplying by 100, the 100 has 2 zeros in it, which forces this decimal to move 2 places to the right. If you multiplied by 1,000, which has 3 zeros and a leading 1, it would make the decimal move 3 places to the right. So the number of zeros after the leading 1 controls how many places the decimal moves. Okay, so in our final step, we're going to be multiply by 100 in order to go all the way to a percent. Okay, that's going to turn it into 70%, and you can see that in your calculator. So times 100, and you get 70. As soon as you multiply 100, you will then put the percent symbol. Okay, so that multiplying by 100 makes the decimal go 2 places to the right. And in fact, you can show it to me like that for this step if you want. Rather than multiplying by 100, just slide it over 2 places and show that that's what you're doing. Okay, we're going to practice that again in example 2. This is the whole population. Population of 40 students. And this is part of the population. Again, using the definition that you see above, if you're headed for a percent, which you are, this says what percent, once again, that's the question. So you're going to set up the fraction first, part over whole. Second step is you're going to turn it into a decimal. So again, this is step 1, is the fraction. Again, if you don't think that you're going to remember this, you can put these steps on your index card. Okay, next step is turning it into a decimal. which is handled by your calculator. Okay, so we're going to go 25 divided by 40. And we get 0.625. Excuse me. Okay, last step. I'm going to multiply by 100. So same steps we did in the previous problem. When you multiply 100, that has 2 zeros in it. It's going to slide this 2 steps over, and it's going to become 62.5, at which point you can put the percentage symbol on. And you can see that in your calculator. So 62.5. Okay, then we have a table, which is a summary table, and we're going to fill that out together. First, we're going to go from a number that has already been presented to us as a percent. We're going to state the meaning, then we're going to turn it into a fraction, then we're going to turn it into a decimal. So the meaning of 23% is 23 parts per 100, because that's what percentage means, parts per 100. As a fraction, it would be 23 parts. This can be read as per, or it can be read as divided by. 23 parts out of 100, so there it is as a fraction. And anytime you want to get a decimal from a fraction, you just enter this in your calculator. So 23 divided by 100 will get you the decimal. And that's 0.23. This time we're going back the opposite direction. Here they present us with the decimal first, and we're going to work it all the way back to what percent it is. Okay, so 0.41 as a fraction would be 41 parts per 100. Written out in words, that fraction would be 41 parts per, that's what this divided by bar means, per 100 parts. And then if you wanted to write it as a percent, this would be 41%. Anytime you want to go from a decimal to a percent, you can either manually slide the decimal 2 places over, or you can multiply it by 100, which I'll put in this other box. I don't want to mess that up. So you could take the 0.41 that they originally gave you, and you can do it this way. Multiply by 100. That will give you 41%. Or you can just take this and slide it over 2 places to the right, and that'll give you 41%. So either way. In example 3, we are asked to convert 0.56 to a percent. So as stated in the 4 examples that I've given thus far, because there was 2 up here, these were 2 of them, and these were 2 more, so this is the 5th example. Doing the same thing, you're going to take your decimal and just multiply by 100. Whenever you want to go from a decimal to a percent, just multiply by 100. That's one way to do it, or just slide the decimal 2 places to the right. Both of those will get you the same answer. Okay, I chose to multiply by 100 rather than slide it 2 places to the right, and you get 56%. Don't forget to put the percent symbol on there when you're converting it to a percent. Okay, all right, now we get to this next page, and this says convert 5% to a decimal. So if what you're doing when you turn it into a percent is either multiplying by 100, which is the same thing as sliding it 2 places to the right, sliding that decimal 2 places to the right, then if you're going to go from something that's already a percent back to this, then you would slide it 2 places to the left. Okay, so when you're trying to go from you're starting off with a percent, not a decimal, and you're trying to go back to a decimal, then you are going to slide the decimal 2 places to the left, which is actually the same thing as dividing by 100. I think it's just easier to slide the decimal. So we got to recognize, where is the decimal in this percent? And it is said that whenever a number does not show the decimal, it is said to be completely on the right of the number. So when you don't see one, some of them you'll actually see it there, but when you don't see it, it is all the way to the right. And you are going to slide the decimal 2 places to the left in order to get rid of this percentage sign and turn it into a decimal, a true decimal. So we're going to slide it around the 5 and then slide it one more time. This empty spot would get filled with a 0, and the decimal's now here instead of where it was at the beginning, all the way on the right. And then this is no longer here once you slide it all the way to the right. So 5% is the same thing as 0.05. Okay, then just reminding you, in case you have forgotten, that the word of usually indicates, in mathematics anyway, it indicates multiplication. You have to be aware of that because you are going to see this appear in many of the math problems that they ask you to perform. So it indicates multiplication. Okay, then this one, what is 50%? You see, you're already seeing that word of in this problem. You want to find out what is 50% of 45. Now we can think about this logically, even though we are going to show our work mathematically. You're going to see your thought process, so you can't just think about the answer, you have to show the answer. So just think about it. 100% of a number is the entire number. 50% is half of the number. So whatever half of 45 is, that's what the answer is going to be. But there's a specific way that you can demonstrate your work that I would like you to show your work. I want you to show that you know how to convert this to a decimal, because you can only use the decimal form of this percentage if you're trying to find a certain percent of a number. You have to use its decimal form. So convert this into a decimal. In other words, slide the decimal that you don't see. It's all the way over here on the right. Sorry about that. 2 places to the left. Sorry about a little noise interference. The word of means multiply, and you are multiplying by 45. So 50% of 45 is 22.5. And that is half of 45. That's your final answer there. This one, you may not think that you see the decimal there, but you have to actually know that 1/2 is really a decimal. If you don't already know that, put it in your calculator and you'll see 1 divided by 2 is the same thing as 0.5. So what you're being given right here is 18.5%. So if you're going to use this percent to find 18.5% of 268, you need to convert this into a completely true decimal without the percent, and then you can find 18.5%. Okay, always use the percent in its decimal form when you're trying to find a percentage of a number. So slide this over 2 places to the left, once to get around the 8, once to get around the 1. The decimal is now going to be here. So 0.185 is the same thing as 18.5. And then we just discussed that the word of in mathematics means to multiply. And we are finding 18.5%, which is what this represents. This represents 18.5% of 268. So you most definitely can show your work. Okay, don't forget, put it in decimal form. That will get rid of the percentage. Multiply to signify that you know what the word of means, and then this is what you are taking 18.5% of. Pop that in your calculator, and you get 49.58. And that's the final answer there. Okay, with regard to graphs, we're going to talk about different kinds of graphs now because you're going to be taking a look at various graphs and answering questions from those graphs, and sometimes you'll be creating your own. You're going to see that in your portfolio projects, those projects that you are going to complete using Excel, you're going to be creating a bar graph. So all of those portfolio projects relate to what you're learning in class. Okay, what the graph that you're seeing right here, this happens to be called a bar graph. And I think that's pretty obvious. There's a bunch of bars that are in this picture, and they all go to signify a certain value for each category. And the definitions here for you. A bar graph is a visual way to compare sizes of different values. These all go up to a different value. And you're comparing parts to other parts, and it's also good when a participant falls into one or more categories. Okay, we're also, another kind of graph we're going to be looking at is pie charts. Those will be on the next page. Okay, so two different kinds of graphs. Okay, the easy question. Now, there would be no work for this. This would be very few problems on the test that I would allow you to not show work because there isn't any. You look at the graph and get the answer. Which month has the most birthdays? It's just whatever the highest bar is. You have 10 birthdays in June. See, 10 birthdays in June. So the answer to this question is June. Which month has the fewest birthdays? Well, just look for the shortest bar, and that shortest bar occurs during August. You only have like less than 2, like 1 birthday in August. So, which month had the fewest birthdays? August. On the next page, we start to look at pie charts and the various percentages that you can talk about with respect to a pie chart. We can also talk about pie charts using degrees because when you travel all the way around a circular figure, there are 360 degrees, and we can use our knowledge of percentages to figure out how many degrees should I devote to each category. Right now you see several categories. I'll just label these for you because, it doesn't print in color, so these all kind of look like similar colors. So this one's dogs, this one's cats, this one's birds. And I'm getting that from right here. This is rabbits. And this is hamsters. Okay, so in this particular problem, it says if there are 80 people surveyed, how many would you expect to have dogs? And what this pie chart is showing is that in any general population, 40% of the population has dogs. %40 of the entire population has dogs. So we're going to practice what we learned on the previous page. We want to show that we understand what it means to employ the word of. It means to multiply. We're going to show that we know that when we are trying to find a percentage of an entire population, we convert it to a decimal. In other words, take the decimal that you don't see. It's really here at the right. When you don't see it, slide it 2 places to the left so that it's a true decimal without a percentage. Show that you know that the word of means multiply, and then use the number that represents the entire population. So it's 0.40 times 80. That's how many people in this population of 80 actually have dogs, if that represents 40%. Okay, so we're going to put that in our calculator. 0.40 represents the 40%. Of is represented by times, and then we're timesing it times 80. So that would be, in a population of 80, 32 people have dogs. And these 32 people represents the 40%. Okay, in this table, what we're going to do is we're going to set up all the numbers so that we can now apply percentages and decimals to what's called a pie chart on the next page. So we're going to do all our calculations right in this table. We're going to carry them over to this pie chart, and then we're going to draw on this pie chart the various degrees that we work to get on the previous page. Okay, let's go back to the chart. You see here that a table has been created. This was actually taken from your book, and this is how a student spends their time. And they have shown that in this table, they mapped out during a certain time period that 15 hours of that total time period was spent in class. 32 hours of the total period of time was spent doing homework, 54 hours doing sleeping, 15 hours working, and 52 hours taking care of other tasks. So the first thing we need to do if we're going to be able to get decimals and percentages and whatnot is we're going to need to know what is the total number of hours. That would represent the entire population of hours. We always need that total number. So we're going to add all these up. Go ahead and put all of those in your calculator and add them up, and that comes out to 168. Then we're going to try and create percentages, and then we're going to relate that to degrees. So when you are trying to create a percentage, let's review what we did on the previous 2 pages. You compare part. This is the part of the 168. You compare the part to the whole. So this is the entire number of hours. This is part of that 168. So part compared to whole. I'm going to go into the calculator and get a decimal. So 15 divided by 168. Now that's a pretty long decimal. That just runs, kind of runs on and on and on. So I'm gonna allow you to round this particular answer off to 3 decimal places, just so that we're not carrying so many numbers like this. So let's just take let's keep 3 of these numbers, rounding off if we need to. 0.089. That number next to it is not strong enough to bump that up, so we're going to stick with 0.089. Okay, then if we truly want to get a percentage, then remember how we went from a decimal to a percentage? We just multiplied by 100. After multiplying by 100, you get 8.9%. Okay, when you want to say how many degrees is 8.9% of an entire circle? Again, when you go around an entire circle, which is what a pie chart is shaped like, you're talking about 360 degrees total. So if you want to know what 8.9% of this total 360 degrees is, then you have to multiply the decimal version of this 8.9%, which is this right here, by 360. Okay, we want to find out what 8.9% Let's review what we did on the previous 2 pages. What is 8.9% of 360 degrees? Because that portion of the circle in degrees should be devoted to class time. Okay, remember, you cannot take 8.9% of 360 while it's in its percentage form. You need to change this to a true decimal without the percentage. That calls for you to slide that over 2 places, but we already know what the decimal version was because you can see it right here. So don't forget, use the decimal number, not the percentage type number. This means multiply by 360, and you get 32 degrees. So 32 degrees out of the total 360 degrees will be devoted to class time on the circle or the pie chart that we are going to be filling out on the next page. Okay, then we come to the next one, and I'll be mimicking those same steps that I did here. We're going to compare the part to the whole. The whole number of hours is 100. The entire number of hours that they investigated was 168, and 32 out of that 168 is spent on homework. We're going to convert it to a decimal by going into our calculator and going 32 divided by 168. Comes out with this run-on decimal. Again, because there's so many digits after the decimal, and they'll allow you to round it to the 3rd decimal place, so 0.190. Or you can just say 0.19, it's up to you. Turning it into a percent requires multiplying by 100, and that is what this column's about, creating a percentage. So this would ultimately be 19%. Okay, so we got 8.9%, we got 19% here. Let's see what else. Now we're going to sleep. Yeah, you probably are falling asleep with what I'm teaching you, but we're going and doing the sleep category, 54 divided by 168. Okay, let's see what that is. 54 divided by 168, and we get 0.321 if we round to that 3rd place. Okay, don't forget to multiply it by 100. I mean, you could do all of these or do each row completely. I'll go up and finish each one just so we have it all completed. Okay, so when you multiply this by 100, it ends up being 32.1%. Okay, if we completely fill out this row, we had 0.190, and if we want to relate that, it really means 19%. If we do want to find 19% of the total 360 degrees that there are in a circle, remember to use the decimal portion, which is just right there. It's the number we had before we turned it into percent. This means multiply. So we would multiply this times this, and if you put that in your calculator, 0.19 times 360, you get 68.4 degrees. Now notice that this column says round to the nearest ones place. So you're not going to give any of this decimal portion. That's the ones place right there. So this is closest to 68 degrees. Okay, then using this right here, again, we really want to find 32.1%, not that you need to write this, of 360. And that is the same thing as saying multiply 0.321, the decimal version of this. This is the decimal version of this. Of means multiply. You're multiplying by 360, and that gives you 116 degrees. Let's just check that out. 0.321 times 360. Yep, and we round that to the ones place. This is the number This 5 is the number in the ones place. Look at the number to the right as we practiced on the first page, rounding off, and that turns out to be 116 degrees. Okay, the 15, we've already done it. It was up here. We have that happening again. So whatever the answers were that we got there, when they asked for a percent, it was 8.9%. That 8.9% was equivalent to 0.089. And we are multiplying that. That's the same thing as finding 8.9% of 360. Now, since I've stipulated here that this decimal is the same as the percentage, I'm not going to keep writing it, because really, when you go to find the number of degrees, you're only using the decimal portion. So 0.089 times 360, just like we got right there, was 32 degrees. You didn't need to show the work again because you already had it here. Okay, so we're going to do 32 degrees for this category, 68 degrees for this category, 116 for the sleep category, 32 degrees for the work category, and then one more. For other tasks, it's 52 out of 168 hours spent on other tasks. This is just how the student spends their entire week. This adds up to the number of hours in a week. But anyway, 52 divided by 168 is, let's see, I'm going to call that, if I round to the third decimal place, as I have with all the other numbers, I'd have to bump that number up to a 10. And part of that 10 would spill into this category. So this would become a 10. So it would be 0.310. And that's what that 5 caused to happen. 0.310. And if you're going to convert it into a percent, you have to multiply by 100, which would turn this into 31%. Okay, then coming over here to get the number of degrees, remember we really only use the decimal percent. I mean, I could continue writing that we're trying to find 31% of 360, which is the same thing as using the decimal version of the 31% times 360. And that turns out to be 112 degrees. Now, sometimes when you add all these up, it won't come out to be exactly 360, and that is simply because of the rounding process. You've been rounding every single answer off, and that can sometimes take you a degree or two away from 360. But we'll check it out. Let's see if this comes out to a full 360. 32 plus 68 plus 116 plus 32 plus 112. Nope, we hit it right on the button. Okay, so now let's take these answers that we worked to get, transfer them over to the next page, and use them in the form of a diagram, a pie chart specifically. So class is 32, homework is 68. Class, we have to devote 32 degrees. Homework was 68 degrees. Let me go grab the other ones. Sleep was 116 and work was 32. Sleep was 116 and I think work was 32. And then the last category was other. And on other tasks during the week, you are going to devote 112 degrees. Okay, then looking at this picture, anything circular can be related to degrees. And as you see, they've laid that out for you. I'm going to count how many spokes there are, or how many division marks there are. Between 0 and 90, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means 90 divided by 9 of these are each worth 10. So 10, 20, 30, 40, 50. So that's how I figured out how much each of these are worth. I just went 90 divided by 9, and I figured out that they're 10 degrees each. So the first place that you want to move to is 32 degrees. So count it out. 10, 20, 30. And then you're just going to go a smidge beyond the 30-degree mark, and that will represent, you're going to just have to approximate it. Okay, so go to 30 and then just a tiny bit beyond that to represent 32. Take this mark all the way into the center. Come out beyond the rim of the circle and label it. That is 32 degrees, and this section right here, that represents 32 degrees of this entire circle, which is 360, and you can label it. That is the number of degrees devoted to class time. Next thing is that you're going to devote an additional 68 degrees to homework. So in other words, from where you're at now, you need to move an additional 68 degrees. So therefore, you're going to have to add to figure out where to land next. You're at 32 degrees. You want to add an additional 68 so you can move 68 degrees beyond the 32. So adding this up, you would have 10, 4, and 6, that's 100. So now that where we're going to land next, as we continue rotating around the circle, we're going to rotate to 100 degrees. This is 90, each one counts for 10, so this would have to be 100. So this portion right here that you're seeing is homework, dedicated to homework. Number of degrees was 68. We moved an additional 68. That made us land on 100. Okay, next thing is you're going to move an additional 116, and you're going to devote that to sleep. So if I move an additional 116, that means I have to add 116. That gets me to 216 degrees. Okay, so if this is 180 down here, and each one of these counts for 10, it's going to be 190, 200, 210, 220. 220 is a little bit too far. 216 would be right before that. Let's estimate it right there and take it all the way into the center. Come out beyond the edge of that circle and label it that this represents 216. And this entire arc that you have moved, this entire circular distance that you've moved right here, which was that 116 degrees, all of that represents sleep, the number of degrees dedicated to sleep. Now we're just labeling where we're landing. Okay, so now we're at 216. We have to move an additional 32 degrees and dedicate that additional 32 degrees to work. So we'll label it work, but let's see where we're going to land. This will be 8, this will be 4, this will be 248 degrees is where we're going to land right now. Okay, so let's estimate that. Let's see. Okay, so this was 216, 220 was that mark right there, 230, 240, 250. And if this is 250 and we're trying to be at 248, then it would just be a little tiny bit before 250. Bring it into the center, come out here and label that you have now landed at 248. And by labeling where you've landed, I'll be able to tell how many degrees you have moved from the last location to where you're at right now. So we just moved 32 degrees, and that 32 degrees can be labeled as work. And then all of this would just be devoted, all of this as you travel full circle all the way back to 0, which would now be called 360 because you've rotated all the way around. So this would represent that last 112 degrees, and we will label it other. Okay, really practice on that. That seems to be a sore spot for students. That concludes section 1.1.